All right, so my fourth set of examples here involves dynamic memory allocation. And so we can, at runtime, create a memory location for a variable, and we need to create, and if we're going to create it, we need to destroy it at runtime as well, because it won't automatically disappear. If we don't destroy once we've allocated memory, we create memory leaks, which is a huge security problem with a lot of software. Okay, so we'll look at a couple examples here of how would create a space in memory to dynamically allocate memory for a variable. Okay, so I'm going to create a pointer. We'll just call it n. And now I need to, so if I go to do anything with n here, it's pointing to absolutely nothing, and I don't have any other variables that I want to develop at this point. So let's just go ahead and create a chunk of memory. Let's ask the operating system, say, hey, give me a chunk of memory here, and I'll use, I'll say n is equal to, and the two statements that I need to be aware of is that we have new and delete. So I need to work with new, so I'll say new, and I want it to be an int. So give me a new integer. And I always free that up somewhere along the line here. And the statement to create it is new, and then I need to say delete that when we're done. So we're all done with this. I need to say delete, and we'll delete n, okay? So on line 7, we've dynamically allocated a chunk of memory, and the chunk of memory happens to be the size of an integer. And then down here in line 9, we've deleted that. So let's do some things with it now. We'll assign it a value, and then we're going to go ahead and let's just print it. We'll say print out the value that's inside n. Space, and let's also print out, just to show we do have a memory address there. We'll print out the memory address of n. Okay, pretty simple little program, but it does demonstrate allocation of a location or a chunk of memory. Let's compile it. Now let's go ahead and run it. Alright, and let's observe the results here. So once we've allocated that, we've assigned it the number 112, and then we've down here in line 9, we've out both the value that's stored inside it and the memory location for it too. And then when we're done, we delete it. Alright, the other area I'd like to demonstrate here is how do we do this same thing in C, because those of us that are moving forward into embedded systems may need to use C here. And the two C commands for allocating memory dynamically and then deallocating it are malloc, stands for memory allocation, and then free. Right, so let's go ahead and we'll write all this in C. We'll use our G++ compiler to compile it, but we don't need this anymore. Well, actually we do, because we're going to use, we'll use the same namespace. We'll use cout, okay? So we need to include another header file here if we're going to use malloc. And for C programmers, we use the standard lib.h. Alright, now I left another manuscript for you, and it's Gupta's notes on how to allocate and deallocate memory in C, and you might want to read through that. I'd suggest that as a good reading exercise for everybody. But I'm going to do the same thing here, and it's really going to be almost identical to what we just did. So I'd say integer, and I'll create a pointer, and then when I go to allocate memory, we just use a little different statement. So first I need to typecast, let my compiler know that this is going to be an integer pointer. Now I allocate memory, and I use the malloc command. Now I have to tell malloc what's the size of this. And there's two ways I can write this. I can write this as simply 4, and that'll work for me. Okay. And now I need to deallocate it here, so I'll free up n. Right? Another way, a little more clever way that I could write this, I could say size of an int. Okay? And that would allocate memory the size of one integer. Alright, let's compile it here. First, let's put some output here. So I'll say cout, and let's just go ahead and, oh, we didn't give it a value yet. And we'll say cout. Okay. I think I'm missing some here, and I believe this needs to be inside of parentheses. So compile it. Oh, I forgot a, what do we got here? An equal sign? Need to assign that. Okay, now let's go ahead and we'll execute it, and we'll kind of observe again. And again, pretty simple algorithm here, but very similar to what we just did, but we're using the C command for allocating memory, which is malloc, and then free it up at the end, which is free.